In this video, we're going to talk about using probability with the normal distribution table to predict what's going to happen in the future based off of probability. So what we have talked about in a couple of the other videos is that the chance of knowing something is going to occur is a very good business concept, especially from business analytics standpoint. If I just have a feeling of what the chance is that something could happen, then I can predict what I need to do in the future. Normal distribution lets me do that. Go back to your probability and stats class that you've taken in the past. You probably remember from the normal distribution. Normal distribution is symmetrical, which means that if I went in here and I put the mean at the very center, the mean is here. If I went one standard deviation to the left and one standard deviation to the right, that says that approximately 2/3 of all of the values are going to fall within one standard deviation of the mean. If I go out to 2 standard deviations from the mean, then I get out to 95% of all of the data should fall within 2 standard deviations of the mean. What does that mean for us from a probability standpoint? It says let's assume that right now a new manufacturer is making a bag of feed, and the bag of feed that they're putting together weighs on average 34 pounds. If I go back to my normal distribution curve, if the average is 34 pounds, then 50% of the time I'm going to either be above 34 or 50% of the time I'm going to be below 34, all right, because it's symmetrical. So the probability that it's going to be less than 34 pounds, 50%, probability that it's going to be more than 34 pounds is 50%. Okay, take that just a little bit further. Now, if I can start thinking about finding out where I am on this table, okay, or on this curve rather, if I can find out where I am on this curve, I can start looking at the probability, because you can see that below 2 standard deviations is only 2.28%. You add another 13.59% going from standard deviation, 2 standard deviations below to 1 standard deviation below. So let's start moving this to a new idea. Let's say if I was going to look at the next bag that comes off of the conveyor belt. And the next bag that comes off the conveyor belt, if my weight was 34 pounds, standard deviation is 10, but I want to guess what's the probability that the next bag that comes off the conveyor is going to be less than or equal to 24 pounds. What it says is, if I wanted to determine what's the probability that the next bag that comes off the conveyor is less than or equal to 24 pounds, then back to the data that I have, 34 is the center, it's the mean, standard deviation is 10, I'm going 1 standard deviation below. Well, the probability that it's going to fall below 2 standard deviation is 2.28%. The chance that it's going to fall between 2 and 1 standard deviation below the mean is another 13.59. So I can say that the probability that the next bag is going to weigh less than 24 pounds is only 15.87%. Okay, we're getting much closer. What we need now is some sort of granularity to determine what happens in between these data points. That's where we bring in the z-table or the normal table. This is in the back of your book, back at Appendix D, Table D1. Table D1 will let you look up the z-score, and the z-score is nothing more than give me the data value that I'm looking at, subtract away the mean, divide it by the standard deviations. At the concept level, the z-score just says how many standard deviations am I away from the mean. Just a few seconds ago, we looked at this. We said 34 was the mean, 24 was the value I was looking at. So here's the value I was looking at. There's the mean, divided by the standard deviation. This is minus 10 over 10. That gives me a z-score of minus 1.0. If I go to the z-table or normal table in the back of the book and I look up minus 1.00, That is 15.87%. Well, that's exactly what we calculated here, but you can now see that I have a table that if I can calculate a z-value, I can now look up any probability in my z-table, okay? One thing that's not shown here is when you do go in your book, the left side of the page is all of my negative scores, and then over here on this side is my positive scores, okay? So they're both there. You just need to know how to go and look for them. You also need to know that it's not always going to pop up to where it's exactly minus 1.00. It could be minus 1.02, which means that you would just have to look that up in the table. All right, almost finished here with this idea. There are 4 steps to calculate the probability with a z-score. I recommend you start off with drawing a picture. Calculate the z-score or z-scores, look up the probability in the normal table back in Appendix D, and then use the probability in the pictures to calculate the answer to your question. Here's an example. Out of your book, 4.14, it says that the mean is 72, standard deviation is 8. Mean is 72, standard deviation is 8. It asks in there what's the probability that the next occurrence that you will see is greater than 60. Draw the picture, get your normal curve drawn out there, put the average in the center. We're looking at 60, draw 60 in here. In particular, we want to know greater than or equal to 60, so we're looking at this amount of data, all of it. Don't worry that this isn't colored in here, it just didn't get colored in. Again, I've drawn it, I'm looking at everything above 60. Step 2, calculate my z-score. My data value is 60. The mean is 72. Standard deviation is 8. I calculate a z-score of minus 1.50. That means right here is a z of minus 1.50. The next step says let's go look at the z-table. And if I look up minus 1.50, I come up with a probability of 0.0668, which means that 0.0668 is in this tail, but that's not the tail that I'm interested in, right? I'm saying what's the probability that's going to be greater than 60. Going back to the complement rule, we know that if we have this tail here and it's 6.68%, all of the rest of this is 1 minus 0.668 or 93.32%. Okay, once again, we drew the picture, we calculated a z-score, looked up the percentage in the z-table, and then we used the percentage to solve the problem. Just one more complexity that we can add to it. Also, example 4.14b in the book says, wait a second, what's the probability that the next value is going to be between 68 and 84? Draw the picture. 72 is the center, 68 is the bottom one I'm looking at, 84 is the top that I'm looking at. In particular, I'm looking at 68 or above and below 84. So this is the area that I'm looking at, okay? The only thing different now is I have 2 values, 68 and 84. So I calculate 2 z-scores. The z-score with 68 comes up to be minus 0.50. I expect minus makes sense since 68 is to the left side of our average. If I look up in the z-table 0.50, I get 0.3085 is this percentage here. If I calculate the z for 84, 84 minus 72 divided by 8 is a positive 1.50 z-score. If I look that up in the z-table, that comes out to be 93.32%. So again, if all of this is colored in, all the way up to 84, all of that data is 93.32. So 93.32 is everything to here. However, I don't want this tail in it. I don't want this 30.85 in there. So I'm taking my 93.32%, subtracting off the 30.85%, gives me 62.47% is all in this area. Okay, hopefully that makes sense, gives you a good idea how to use it. Once again, very important concept on being able to calculate probability using the normal distribution.